We are trying to define the boundaries between what quantum computers can do compared to supercomputers. It's not clear what are the limits of this type of computation. My name is Berta Casas and I'm a PhD student at the Barcelona Supercomputing Center. I work in the quantum group. I started working here in 2022 when I was doing my master's thesis. I studied physics at University of Barcelona and the master was about quantum science and technology. We are trying to define the boundaries between what quantum computers can do compared to supercomputers. It's not clear what are the limits of this type of computation. Quantum computers were originally proposed to solve quantum physics simulation problems. So what we expect is that in the future, quantum computers will be able to simulate very small subsystems or like materials, for example, that work under the law of quantum physics much more efficiently than what we can do with supercomputers or other classical technologies. Quantum physics is the area of physics that studies small things, and when we go to the microscopic level, things work with different laws. The basic information of a quantum computer is the qubit, which is the quantum version of the bit. A qubit can be in a state of 0 or 1, like bit in a classical computer, but it can also be in a superposition of states. This is one of the properties that quantum computers leverage to enable new type of algorithms. When we're trying to simulate a quantum system, the space that we have to track in the simulation grows exponentially. And this means that when we add particles, the space grows very, very fast. And for example, if we want to simulate exactly 20 particles, that is like a normal or regular number, we cannot do it in MareNostrum because the space is so large that we don't have like the computational power to do it. The quantum computer that we have here at BSC is funded by the Quantum Spain project. Thanks to these projects, scientists around Spain are collaborating to understand what we can do with quantum computers in supercomputing centers. For example, right now, what we are doing with the quantum computer at BSC is to try to integrate it with MareNostrum 5 and try to build a workflow that is basically a communication system between the quantum computer and MareNostrum 5.